Somehow, I'm a sophomore at Brown University studying math, and my submission for the AI Agents Intensive Capstone in the freestyle track is LeanScribe. LeanScribe is an AI agent that cannot lie, but when you put in a plain English math statement, it proves it using Lean 4. LLMs are confident, fluent, and wrong. Originally, when I was designing this, I used Gemini 2.5 Pro, and it was hallucinating different theorem names, things from MathLib that were just not right. And it would say it in a way that looked perfectly right, but was completely wrong if you took a closer look at it. For anything where the user has to tell the actual difference between right and wrong, you need an external verifier. So I designed LeanScribe to ground every model claim in an external verifier before the user even sees it. So this happens to be a perfect task for an agent because there's a loop, an iterative loop, where you can take a proof, check it, find where the errors are, and recheck it again until you get a correct proof, then ship that. So you get so you can check it using the oracle, and then the errors are structured so it tells you where to improve. You can use Lugal and a tool. We use a skill for search, which searches Lugal for the right MathLib lemmas. And then we also have tactics for specific problems such as divisibility and primality, like arithmetic arguments. And so those are wrapped inside little tactics skills where you can search the right tools to use for a specific problem. So the LLM works as a glue in the search heuristic, and the correctness is outsourced to the kernel. So here's how it works. We have an orchestrator.py file, which organizes 4 ADK agents. The planner first turns your English proof, your natural language proof, into a lean checked theorem statement. Then the formalizer writes an initial proof. The repair agent checks it and reads the goal states and creates patches for the errors that occur. So anytime the lean thing checks it, finds goal states, the repair agent looks at it and patches it. Then when that loop is done, the verifier checks whether the statement the agent proved is actually the statement you started with. And we'll get to that in a second. Everything works inside a sandbox. So everything is behind the Lean MCP server, where you get 4 tools. You get compile as the oracle, the search premises to search Lugal, run tactic as the writer so you can write code, and then you have check statement, which checks it and sees where to improve. Everything is inside a no network, read-only MathLib sandbox with CPU limits. So you're never going to have something take over your computer or ship anything bad. And one thing that we use is that we use a warm lean REPL. So MathLib only loads once, and then every compile after it is cheap. So everything we do, the best of anything, is totally affordable. So the thing about just using it as a prompt or just having a natural lean thing is that an agent can often turn a natural language statement into something easier to prove and then prove that. And that's much harder to look at from a human perspective. So for example, if I prove that square root 2 is irrational, I just set it equal to true, that's worthless. It's just proving that true is true. And it's not the statement we initially gave it. So we use a deterministic perspective to identify exactly where it's changed and identify whether a statement drift has occurred. So any sort of vacuous conclusions are rejected immediately. Then the LLM just translates the statement that's the statement that's formalized back into English so we can see what the comparative claim is. And so everything's deterministic. So the LLM never judges whether the proof is the same. You have an actual kernel checking whether it's deterministic or whether the statement that you started with and the statement you proved is the same. So LeanScribe check means that it's proved and proved the actual theorem that you started with. So I'm going to show you guys a live demo. I'm going to say that n cubed minus n is divisible by 3. So it's going to run. So here you have the thing is starting up. But first you have the planner agent that sketches the proof, the premise search, which is the Lugal skill, and the formalize agent goes in, writes it down, compiles it. The verifier checks whether the back translation or the thing is the same, and it back translates it into English. This is the same. And the kernel checks it. And we can do another one if we want to. I'll skip it for now, but you can try it on your own. So the thing follows the exact course path. So we use a multi-agent ADK that uses a planner, formalizer, repair, and verifier. We use MCP servers to get everything behind tools and use a warm REPL backend. Security is everything is sandboxed. Agent skills, of course, and anti-gravity is built in. And then it's deployed. You can deploy it as a containerized Lean MCP and a Vertex AI engine script. So here's what we got. We use a Putnam style bank, not Putnam problems, much easier than that, but we have like insight-based ones. We got 7 out of 9 correct, 0 statement drift, and 2 honest misses. So we ran it with a timeout, and it just hit the timeout before finishing, and it never submitted a wrong proof. So this principle generalizes. You ground every model claim in an external verifier, and if you type checks, it's correct. So even though it is the proving ground of mathematics, it could exist in sort of any sort of domain where truth is meaningful and exists in some real sense. So this is LeanScribe, and you can find it at github.com. Thank you.